Okay, we continue looking at how to forecast and be able to manage old history versus new history. We looked at moving average, which is a very straightforward method, a little bit more elegant method that does the same thing. It's just probably easier to manipulate is exponential smoothing. In exponential smoothing, what we do is that our input parameter is a smoothing constant. And all it is, it tells us how much weight we give to what just happened and how much weight to give to old history. The exponential part, I'm not going to go into what that part is, but just know that it allows us to weigh old history versus new history using a parameter called a smoothing constant. So I'm going to go back to this large data set where we're looking at houses sold, and I'm going to insert some columns. And this is going to be an exponential smoothing. Now, exponential smoothing has also a parameter, and I'm going to put that in column. I'm going to actually insert a row above and put it above it. So my smoothing constant is called alpha. It's a number between 0 and 1. It can be 0 or any real number up to 1. If it is 0, then it gives very little weight to what just happened and all the weight to historical information, old history. If it's 1, it only gives weight to just what happened and no weight to old history. So you decide what that is. So right now I'm going to put it at 0.5, right in the middle. So we don't forecast the first one. We'll talk about that in a minute. We need to start with the second. But what we do, what an exponential smoothing constant does, it takes this smoothing constant and says, I want 0.5 of this plus 1 minus alpha, or 1 minus 0.5 of the one above it. So look what it does. It takes a weighted average of this and this. So I'm going to take 0.5 alpha times my previous actual plus 1 minus alpha times my previous forecast. Now, I don't have a previous forecast for the first one, but that's okay. There's nothing wrong with that. I'm going to copy this formula down, so I'm going to put some dollar signs around my smoothing constant. And because I don't have anything, well, it's not a very good forecast. This is what really happened, and this is what it projects. If I would have a better starting point for the very first one, it would be better. But we're not going to worry about that because we have enough data eventually that doesn't make any difference. But we'll talk about that later. So now I'm going to just copy that down. And again, all these decimal points, we don't need to show those. That's just Excel not knowing to keep them to significant digits. So that's an exponential smoothing with alpha equal to 0.5. Now let's add that to our plot. So I'm going to get rid of the red, but I'm going to add another data point, and I'm going to add exponential smoothing. My x values are again all of my years, and my y values in this case are going to be my exponential smoothing numbers. And actually that's really good. I'm going to get rid of the green. So that's with alpha equal to 0.5. Well, let's put it at 0. And that means that whatever happened just now, I don't care. And look what happens. Because I don't have an initial condition, it just says I want 0 of this plus 0 of this. And that this is always going to be 0 of this plus 1 of this. So I need to have a starting point for this that makes sense. Let's start with 400. Actually, we'll just start with the very first one. And so essentially the very first, which is the oldest history data point, gets all of the weight. And it just takes and gives all the weight to that if we have alpha equal to 0. If I have alpha really small, then it takes a long time for it to change. You can see it takes a lot of data because it only takes 0.001 of this plus 1 minus 0.001 of the old one. So it takes a long time to change. But as alpha gets bigger, and they got bigger, got really good really fast. So let's start. You can see, make it 0.06, starts getting better, 0.07, 0.1, 0.2, 0.5, where we were, that's looking really good, 0.6, looks like we're starting to, that's about as good as we can get. We could go all the way to 1. And when it's 1, it's a little bit unfair to see, but what that does, it completely ignores what just happened. So I could put that back to 0, and it gives all the weight to the previous one. So basically, when alpha is equal to 1, it gives all the weight to this one and ignores this one. So a alpha that's larger gives all the weight to what just happened, no weight to old history. It gives more weight to new history. So when alpha is equal to 1, it's a very reactive forecast. When alpha is really small, it's a very slow to react forecast. Okay, we're going to, later on when we talk about forecast accuracy, we're going to determine what should the best alpha be. Thanks.